Alright, so let's look at this tug. Alright, and what I want to do with this tug is just sort of see if I know how much the tension is in this rope, how can I find the water resistance on the barge? Okay, so we're just going to say this thing has 4 tons of tension in it. And then we'll just figure out, use that to figure out how much force or the water has on the tug. This is a stable situation, or not the tug, the barge. So this guy's just going to tug. The tug is just going to putter around here with the constant speed v. Okay, and let's put that in the x direction. So as a constant speed v, this rope is going to pull in the same direction. So we'll have a tension here T from the rope. There's a weight to this, so there's some weight on my barge. That's a force. There's also some force keeping it up. That's called the buoyant force, pushing it up. And then we have a drag force, a force of water resistance pulling it back. So this is a forces diagram. Basically what it is, you have some axes and you just draw the forces on it to help you figure out what's going on. From this, we can read this, we can say in the y direction, T minus D is equal to 0. And in the x direction, and in the y direction, B minus W is equal to 0. So that's like saying the tension is going to be equal to the drag force and the buoyancy is going to be equal to the weight. We only care about the drag force, so we want this guy. We know the tension, right? The rope is pulling with 4 tons of force, so we don't need the y direction at all. It's extra information from drawing this figure. When we got the information we needed, which was this, the T minus D equals 0. So that's no big deal. We know the tension is 4 tons. Minus D is equal to 0. Well, that just means that D is equal to 4 tons. And, we'll want this in pounds, so 2,000 pounds equals 1 ton. So that means we have 8,000 pounds of force. So all we did here was first we drew a little picture here, a force diagram, so that we can find all of these forces from the tug, right? The tug is coming here with a constant speed. That means that there's a force here, T. The drag force, the water resistance is going straight back. The tug is pulling straight forward. There's a weight coming down and some buoyant force keeping it afloat. That told us that T and D had to balance. T minus D is equal to 0. So that made our math really easy. D is equal to T. D is equal to 4 tons. The problem wanted it in pounds of force, so we just converted, which is 2,000 pounds in 1 ton, so that means that there's 8,000 pounds of force in the drag. Next we'll go on to weight. Bye now.